Well, good morning, pre-calculus students. We're ready to do another video, and we're ready to move into chapter 9. So we're going to look at combinatorics today. Just as a reminder, so we're going to do chapters 8, 9, and 10, and then we'll have a single test on those. And what I'll probably do is I'll hold off, rather we didn't assign any review from chapter 8. I think the best way to do it will be to do all of 8, 9, and 10, and then spend about a week doing review before we have the test. So that way I think you'll actually get the best, and the review will be fresh in your mind, rather than doing a review from chapter 8 and then not doing anything from chapter 8 all the way until the test. I think this will be the best way to freshen up your memory right before the test and have you best prepared to do it all. So that's the plan. So we're moving into chapter 9. Each one of these chapters is fairly short. Chapter 8, as you remember, we only did 4 sections. Chapter 9, I think it's 5 sections, and chapter 10 is only going to be, I think, maybe 4 sections. So pretty short overall chapters. It'll be a longer test, but once again, it's not going to be like a test over 3 chapters where each chapter's got like 7 or 8 sections to it, something like that. It won't be like that. So it won't be like a final in that sense where it's covering a whole semester's worth of material or anything like that. It won't even be covering a whole quarter's worth of material. It'll only be covering about half of a quarter. Okay, maybe 2/3. Let's go ahead and let's look at combinatorics. Combinatorics is really just a fancy way of saying counting. This is ways of counting. Obviously, one way of counting is going 1, 2, 3, 4, but a lot of times that's prohibitive because they're just too big a numbers. It takes too long to count that way, so we want shortcuts to counting things. So that's what we're really talking about with combinatorics. Okay, so we are talking about counting the possibilities and shortcuts to counting possibilities. So essentially, we're talking about counting the different ways that something can occur. All right, let's look a little further. So let's look at our principal methods of combinatorics. So we have different methods of counting. Let's look at what they are. So the first method of counting is the multiplication principle. And so the multiplication principle basically means multiplying the possibilities for each location in an array. So in other words, if we've got 3 different spots or locations, and each location has 6 different ways that something can happen, what we end up doing is we end up multiplying 6 times 6 times 6 like that to get our total possible combinations. That's the type of thing that we'll be doing. That's where the multiplication principle comes into effect. All right, the next way of counting, so let's talk first. The best example of this is the license plate example. So if we consider a license plate where you have 3 letters followed by 3 numbers, essentially what you have is you've got 3 locations for a letter, and you've got 3 locations there for a number. So if we look at that, we have these locations right here. So we've got 3 spots that are occupied by letters, and then 3 spots that are occupied by numbers. And notice there are 26 possibilities for each letter, and there are 10 possibilities for each number. Be careful. Remember, it is 10 possibilities. While we can't put a number 10 in there, we can put a number 0. So we have 0 through 9, which is 10 different options there. So when we consider using this model for license plate, obviously we could ask, and we want to know, how many different license plates could we have? Well, we could count. Literally, we could say, well, we could have A000. That's one possibility. We could go AAA001. That's our second possibility. Obviously, you can see we don't want to do this. This would take us forever. So we need a quicker way to do it. And that's where this multiplication principle comes into play. So those are our letters. Those are our numbers. And so the number of combinations or number of possible license plates we could have, we know it's going to be 26 to the third, or 26 times 26 times 26 times 10 to the third. And when we do the multiplication there, we get 17,576,000 different possible combinations of license plates. So quite a few different license plates. Now, some ways that we could get more combinations. There is a number of different ways we could get more combinations. In Oregon, one of the things that they did is after they ran out of this wasn't enough anymore, what they did is they just said, instead of going letters and numbers, we'll go 3 numbers and then 3 letters. And as you can guess, what that would do is, by switching that around, that gave them another 17,576,000. So it doubled the possibilities. Well, there are other possible ways you can get more. One of them is, instead of restricting it to be all letters and all numbers, or all numbers and all letters, what if we just let it be random? What if we let it be numbers or letters and we just have 6 different spots? Well, that would be 36 possibilities for each spot, 26 letters or 10 numbers, and there would be 6 spots, so it would be 36 to the 6th. That would actually give us over 2 billion possible combinations. So as we can see, that gives us a whole lot more different possibilities. Sometimes what they'll do is sometimes they'll just simply add an additional spot. So instead of 6, they'll add a 7th spot, either an extra letter or an extra number. So you could imagine if I added an extra number, that would give me 170 million, as I would simply multiply by 10. If I added an extra letter, I would have to multiply this by 26 to get the number of possibilities. So a number of different things I could do to get more possibilities. Okay, another situation that arises, the multiplication principle works great when we're just considering the number of possibilities per spot. One of the things that happens, though, is what happens when the number of possibilities per spot decreases because you can't reuse something. So in a license plate, you can use A. But what if you have a situation where once you use A here, it can't be used again? So that's when we come into what's called a permutation. Permutation comes when there's no repeating that is allowed. But also, order is important. So if we change the order, it does change the combination. It does change the actual outcome. So sometimes order isn't important. Like in a poker hand or a card hand, it doesn't matter what order the cards are in because you can move them however you want to. But in other things, order is important. So like, for instance, in a license plate, it does make a difference whether it would be ABC or whether it would be CBA. Those are different combinations. Okay, so with permutations, here's an example. What we're going to do, we're going to select a president, a vice president, and a secretary from 12 students. And so order does matter. It is a different grouping if you pick Bob as president, Susan as vice president, and Jenny as secretary, than if you went Jenny as president, Bob as vice president, and Susan as secretary. That's a different combination. So order does matter, but we can't pick and go Jenny, Jenny, and Jenny. That doesn't work. So we can only use each person once. We cannot repeat. So here's the situation. So we consider the multiplication principle is still in effect. So what we look at this, we say we have 12 possibilities for president, but once we pick a president, how many possibilities do we have for vice president? Well, we can't use the person we pick for president, so we only have 11 possibilities. And then for secretary, once we've picked a president and a vice president, we only have 10 possibilities left for our secretary. So it's still the multiplication principle, 12 times 11 times 10, and that ends up being equal to 1,320. But sometimes with permutations, they follow this pattern, and so we don't always want to just do it simply with multiplication type principle. We want to establish a mathematical rule that gives us this pattern. And what we do is we establish this rule. We call it our rule for permutations. This is the notation that we write it. We write 12 people permutated for 3 different locations. So we write this 12p3 like that. And there's a formula for calculating it. And it goes like this: 12 factorial over 12 minus 3 factorial, which ends up being 12 factorial over 9 factorial. Now, at this point, you're probably asking, well, what on earth is factorial? Oh, you may remember from looking at it before, but factorial is this. If we have a number and we look at the number factorial signified by the exclamation point, n factorial means we take n times n minus 1 times n minus 2 times n minus 3 and so forth all the way until we get down to 1. So for instance, 12 factorial would be 12 times 11 times 10 times 9 times 8, so forth. So permutations always fall in this category. When we have n permutated for r spots, we have n factorial over n minus r factorial. So notice going back here, what that means is we have the 12 factorial, but we're dividing it by the 9 factorial. So that means that the 9 factorial cancels out with the 9 times 8 times 7. And so all we have is the 12 times 11 times 10, and then the rest of it cancels out with the 9 factorial. That's what's happening there. Okay, so if we have n items permutated for r spots, this is the formula that we use. That's the way that we read that. All right, the other thing we can look at are called combinations. Combinations are like permutations, except now order is not important. So this is things like if we pick a 3-person committee. Whereas a committee, it doesn't matter what order the people are in, they're just on a committee. So combination uses the following formula. We use this notation, the number of people combined for r different spots. And this is our formula, n factorial over r factorial times n minus r factorial. So for example, if we're going to select a committee of 3 from the 12 students. So now we're not doing a president, vice president, and secretary. We are just selecting a committee. So that's going to follow this pattern here. 12C3. And in order to do that, we are going to go 12 factorial over our r factorial, which is 3 factorial, times 9 factorial. Now, when these numbers aren't too big, you do need to be able to do this by hand. When the numbers get big, we can do this with our calculator, and we'll show you there's actually a feature where you can enter it directly into your calculator. But you do need to know the formula so you can do it by hand. So if I set this up to do by hand, I know this is going to be 12 factorial. So that's 12 times 11 times 10 times 9, and it keeps going. So I'm just going to do that. And this is 9 factorial down here, so it will cancel with this 9 factorial. But notice I still have this 12 factorial over, I have 12 times 11 times 10 over 3 factorial. So I can write that like that. Now I can cancel out. And I can do this a number of different ways. I would notice here that this 6 cancels with the 12 to give me just 2 times 11 times 10. And write it like that. That's pretty easy to do. 2 times 11 is 22 times 10 would be 220. And that's the way we would do that. All right, last thing, let's consider just how we would do this with our calculator, since there is a method for doing this with our calculator. So let me pull out the calculator and show you. So if I'm going to do this on my calculator, I'll do the 12. I'll do both the combination and I'll do the permutation and the combination. So first the permutation. Now obviously I can just enter it like you see it and do all the division. The factorial is found in your calculator under this button right here. So you see this button right here. Use my pointer to point it out. That button right there, if you hit that, so I will hit that button there on my calculator. And notice up pops this menu, and the factorial is my second choice there. So if I want to just do something like 12 factorial, I can just enter that symbol, and do something like 12, and then enter the factorial, and it will give you the answer for 12 factorial. If I want to do something like 12, a permutation, 12 permutated for 3 spots, I can go to my menu button, and I can choose the probability, which is choice 5, And notice under the menu probability choice 5, we have permutations. We also have factorial there. That's another way to get to factorial. And I have my number of spots, 12, for 3 spots like that. And I can enter it just like that, 12, 3, and hit enter. And I get my 1,320. If I want to do the combination, once again, menu, I can go to probability, which is choice 5. I can go down to combinations, and I get my NCR, my N things combined for R spots. So I can go 12, 3, and I get my 220, just like I did the other way. So that's how you enter it with your calculator. So those are where it's located on the calculator. So you need to be able to do it by hand when it's relatively simple numbers, like this example here. But if it's very big things, like for instance 60 things combined for 5 spots or something like that, well, then you're going to have to use your calculator. So you should be able to do that with the calculator. If they're big things like the license plate examples using multiplication, use the calculator. All right, there's your homework, 9.1, 1 through 22 all. So go ahead and do those, and we will be having a Zoom session today at 12:45. Okay, I hope you're doing well, and talk to you again by video tomorrow.